In this part, I want to use the fundamental identity to solve some trig function problems. Okay, before that, let me recall the fundamental identities. What we have, the first one is the reciprocal identity. So the sine u is equal to 1 over cosecant u. Tangent u is, cosine u is equal to 1 over secant u. Tangent u is 1 over cotangent u. And we also have the quotient identity, which is the tangent u is equal to sine u over cosine u. Cotangent u is equal to cosine u over sine u. Right, we also have the Pythagorean identity. Sine square of u plus cosine square of u is equal to 1. 1 plus tangent square of u equals secant square of u. And 1 plus cotangent square of u equals cosecant square of u. And we also have the cofunction identities. That means sine of the pi over 2 minus u equals the cofunction, which is the cosine of u. And cosine pi over 2 minus u is equal to sine u. And tangent pi over 2 minus u is equal to cotangent of u. Cotangent pi over 2 minus u is equal to tangent of u. Secant pi over 2 minus u is equal to cosecant u. Cosecant pi over 2 minus u is equal to secant of u. So these are called the cofunction identities. The cofunction of the complementary angles are equal, right? And then we have the odd or even identities. So that means the sine of negative u is equal to negative sine u. Right? So this kind of identity we can deal with the negative sign inside this function. Right? Cosine of negative u is equal to cosine of u. Tangent of negative u is equal to negative tangent u. Cosecant of negative u is equal to negative cosecant u. Secant negative u is equal to secant of u. Cotangent negative u is equal to negative cotangent of u. Okay, so now we will use these identities to solve some problems. Example, if we know the secant of u is equal to negative 3 over 2, and the tangent of u is greater than 0. Okay, so we know that secant is the 1 over cosine, so cosine u is equal to 1 over secant, right? So we need to find the values of what? Find the values of trig functions. Trig function values. right? So we can calculate cosine first. Cosine is the secant of u, which is equal to -2/3, right? And cosine, so the next thing is sine. Sine, we can use the Pythagorean theorem, right? Pythagorean theorem using this identity. But if you take the square root, you have the plus or minus, right? This is the question: which quadrant this u belongs to? Okay, it will make sine u to be plus or to be negative, positive or negative, right? We know that cosine u equals a negative number, so it means u is in the which quadrant? The second and the third quadrant, right? And we also know tangent of u is greater than 0, so that means u is in the first and the third quadrant. So you put together, so because these two conditions should be satisfied simultaneously, so u is in the third quadrant. Okay, u is in the third quadrant, so the sine in the third quadrant, sine is negative, right? Sine u should be equal to negative square root 1 minus cosine square. So here we use the Pythagorean theorem, but we take the square root, it's a negative number. The reason is u is in the third quadrant. So if you plug in everything, you can calculate it's equal to negative square root 5/3. Okay, since we have the sine, so we can calculate the cosecant u, which is 1/sine, right? So this one would be negative 3/5. Then we have the tangent, right? Tangent to u is equal to sine u over cosine u. So this number over this number, so it's equal to square root 5/2, right? And we also have the cotangent of u. Cotangent of u is 1/tangent of u. Of course, you can use cosine over sine, it doesn't matter. So it's 2/5, right? So we find the values for the trig functions of this u, see the angle u. So now let's look at another example. We want to simplify the following: sine x times cosine square x minus sine x. Okay, so we simplify, so it's equal to what? Equal to, we take the sine out, so this one would be cosine square minus 1. Cosine square minus 1, we know that sine square plus cosine square equals 1, so cosine square minus 1 is equal to what? Negative sine square, right? So it's negative sine cube x. Okay, so next thing is we want to factorize secant theta plus minus 1. Okay, so it's not hard, we just treat this one as a 1 square, so you can use a square minus b square equals a plus b times a minus b, right? So we can use this identity, so it's the secant theta minus 1 times secant theta plus 1. Right. If we want to factorize this one, 4 tangent square plus tangent theta minus 3. So we treat tangent theta as a variable, right? So you can factorize it. If you treat this tangent theta as x, so it looks like the 4x squared plus x minus 3, right? You can factorize it. So it's equal to 4 tangent theta minus 3 times cotangent theta plus 1, right? Okay, another example, we want to simplify sine t plus cotangent of t times cosine t. So sometimes, in order to distinguish the function name and the input, so sometimes we'd like to put the parentheses to represent this t as an input, right? Otherwise, it will be very messy. Okay. So now for this kind of problem, but basic idea is we change everything in terms of sine and cosine. Okay. Let's see what happens later. So this is the cosine t over sine t times cosine t, right? So it becomes sine t plus sine t. This is cosine squared t, right? So we have the common denominator sine t. So it becomes sine t squared, sine squared t plus cosine squared t. So we know sine squared plus cosine is 1, so it's 1 over sine t. Or you can just change it if that would be fine. But if you want to write it as which is cosecant of t, that's okay. Another example, sine theta over 1 plus cosine theta plus cosine theta over sine theta. Okay, so the idea is we just combine the fractions. So we have the common denominator sine theta times 1 plus cosine theta. So this term becomes sine theta times sine theta, so sine squared plus cosine theta times 1 plus cosine theta, right? We expand it. So this is the sine theta times 1 plus cosine theta sine squared plus cosine theta plus cosine squared. So we know sine squared plus cosine equals 1, so it's 1 plus cosine theta over sine theta times 1 plus cosine theta. And this is you can eliminate, it becomes 1, so it's 1 over sine theta, right? So which is cosecant theta. Okay. The next one, we want to rewrite it not in the fractional force, okay? One over 1 plus sine x. Rewrite this one not in fractional form. Okay, we don't want to have the denominator, right? So the idea is 1 plus sine x. Okay, so in order to get some, so we can write this one as 1 plus sine x times 1 minus sine x. Of course, the top is also 1 minus sine, so we didn't change anything, right? So it's equal to 1 minus sine x. This is 1 minus sine squared. So it's 1 minus sine x over cosine squared, right? So it can be written as cosine squared minus sine x over cosine squared. Okay, so cosine is 1 over cosine squared, which is the secant square, right? So we have no fraction for this part. This one is sine x over cosine x times 1 over cosine x. So this is the secant square minus tangent x times secant x. Another one, we have the natural log of the absolute value of cosecant theta plus natural log of the absolute value. Why we have the absolute value? The reason is we needed to make sure this part to be positive, right? This is the domain for the logarithmic function. So we have natural log cosecant theta times tangent theta, right? So we just write one more step, right? So if you combine, we use the properties for the logarithmic function. So it's equal to cosecant theta times tangent theta. Let's simplify how to change everything in terms of x sine and cosine. So this is the 1 over sine. Sorry, this is not x. It's theta times sine theta over cosine theta. So this is the natural log of 1 over cosine theta. Okay, so cosine theta equals what? Secant theta absolute value.